recording, and this time we're going to turn on a timer. Alright, so I got a timer, and let's refresh, make sure we didn't break anything. And it looks like we have some broken shit. Cannot read GL get uniform location of null. And it's this context graphics. So let's, I am pretty sure, so let's go in here and refresh. Or not. Or you could just be stupid. What the hell? What the fuck? You know, break is supposed to, so in Chrome, right, if you put a break, it's supposed to break before the line executes, right? So it's not supposed to be evaluated yet. But you notice that when it broke, it gave me an error and it wouldn't let me, like, inspect it. So this adapter graphics and context graphics, so it is supposed to be in there because it's not undefined. It actually is there, but it has not been set yet. So well, the first thing we're going to do before we fix that issue is we're just going to add some more manual error checking. So we're going to take the checking for that context, and this is in the put, isn't it? Oh, U32 location. Hold on. U32 location. I'm gonna full screen this. Yeah, that would come from the put, and I don't see anything. I thought, what the fuck? U32 put is way up here, and that's null. And it just does that not count as false? Oh, is that because? So null is object in JavaScript, and it evaluates to truthy. So because I'm using a double equals, right? I'm checking. I'm basically asking if this is falsy, and it's not falsy. It's actually truthy because it's null, and null is an object. That's, you know, annoying as hell. But I guess if we think about it, this is supposed to be an object, so why are we comparing with false when we should be comparing with, like, true with null? So let's fix that. So we're gonna say I'm gonna do this. I'm gonna say if false or true. And then I'm gonna say expect not a bool, you know. So some type checking, and then we'll do down here, we'll do if null equals adapter graphics dot context graphics, and then we'll do the previous right here. So we'll do the previous error message with the missing error message. Okay, so now that we have that, and let's refresh this because we expect our error checking code to get tripped rather than a runtime instead of a Yeah, so there. So now we're getting our code to execute. Basically, I want, if an error gets thrown in the code, I would like it to be my own error rather than a built-in error from the V8 engine. Because if it's my own error, then it's something I anticipated, which means that I will have a better idea of how to fix it because I know why it's going wrong, likely. Okay, so let's take all of that, and let's also put this into the... So we have the put, and we should also throw this into the getter as well. Error checking inputs. Okay. U32 get, so we'll just replace these error message with U32 get, and then adapter graphics dot context graphics, and that way, just in case we try to get the value before we set it, which we probably shouldn't do in the first place, but let's not worry about that. So let's refresh. And it's still in the put. So let's fix that now. Now that I've made sure I was just looking over here. Now that I've made sure that that's what's going on, we're gonna go to the U32 put call, and we're going to address the issue, which is okay. So this is right here, right? We haven't set the context in there yet, and we're using it. So what I'll do is we'll just put this up here, and so below depends on adapter graphics dot context graphics. Alright, we'll just make a little note there. So that way we kind of know that we can't put this outside of here, right? And then, you know, since we already have this, for symmetry's sake, we can put, you know, above. And then I don't really like how I can't do that, so I'm gonna do it like that. So that way I can highlight these depends on, and I can see that. Okay. So now if we refresh this, I've never used this object before, so there's a potential that that it's not going to work anyways. Well, we're about to see. So we're about to get that uniform location. Oh, sorry. Let me put this over here. We're about to get that uniform location. Let's see what happens. And that didn't seem right. Refresh. Okay, dot get uniform location. We have some type of error. And what's the failed to execute get uniform location on WebGL2 rendering context. Parameter 1 is a not of type WebGL program. Really? Because I was pretty sure that unless okay, so there's the possibility that that might be null or something. So if I refresh this, okay, so the all program is undefined and it's not even in the container. So we got our GPU. Okay, and that's why we have the adapter graphics, so that we can put that all program in there. So let's go do that. So there was Adapter graphics dot all program equals, I think we should just be able to call it all program, because it doesn't actually, it's in here, but it hasn't been, it's just kind of like floating around. Yeah. And so, since I'm using it there, I should declare it here as well, and I am sealing the object, so I think if I do that, I want to see where the error shows up now, because it might silently ignore. Well, let's use use strict right here. Use strict. It might silently ignore me trying to add the all program object to the container. But I put use strict on, so we're gonna try to reload this and see where it complains. Okay, breakpoint. No? What the reference? Oh, wow. Well, it found a problem alright, but, not the one adapter graphics. Okay, so spelling that correctly, I had a, oh boy, cancel. I had a typo right here. It was called, I didn't spell that correctly, so let's go back here. Let's give this another run. And the console, what is the console saying? Cannot add property all pro for all program. And that is right here. Okay, that's what I expected. I just wanted to make sure that that object.seal was actually doing its intended purpose. So we'll go back up to the up to here, and we'll add the all programs. So all programs. So is null the WebGL program, our main WebGL program object. Now, do we want to put the other things in it as well? Like, I don't think I'm ever going to. Sorry. So in this container, I just added this. Do we want to add the other programs? I don't think I have a use for the other programs. But the part of me that really wants to organize things really wants me to put in the vertex program and the fragment shader program. I'll just be like, probably won't use added for completeness. That's pretty long comment. I do this. And then, with this little tag here, I'm just gonna go down in my comments. I'm just gonna go to the bottom of the file, and, notes/comments. So the idea of putting notes/comments down at the very bottom is, right, comments can clutter the code. So when I think I'm unnecessarily cluttering code, or I like run out of room, then I just kind of like dump notes in the bottom, right? So then I can just be like this. Probably won't use added for completeness. I didn't think I would need this, but I added it into the code anyways because it and then I can take this. I'm just going to take this, put this in my personal notes as well, so that if I ever see this, I don't have to go to the bottom of the file. I can check in my personal notes about what that means. So PWU AFC, PWU AFC, PWU AFC. And, alright. So I added a note in my shortcuts so that I can type, I'll be able to type this in the future to see what that stands for. And so now we can actually go back to that note where we decided that the vertex program and the fragment program should also be added. And we're going to clear our token highlighting, and we're going to scan the file for these two guys, right? So they should be defined somewhere in here. And, okay, so we see they're just loose variables floating around. So what we can do is we can go all the way down to the bottom of the function, and it would make sense to kind of like just start adding them in, so the vertex program and the fragment program. We'll just add those. We could do it like this. So now we're certain that we didn't make a mistake, and we can double click, make sure that these are all lined up, that we haven't transposed anything. And then with that, populate missing components in container. And yeah, so we'll do that. And I think that's all we need to get this code running. I shouldn't have any more errors. So let's go back here. Let's refresh this. Okay, so I don't see any problems. Oh, well, there we go. Not extensible. If I lock it, can I not? Not extensible. Oh, this says adapter graphics. But that shouldn't be. Yeah, that's just me not being smart. And that's kind of why why I've been freezing or sealing objects, so that I don't, I'm trying to protect myself from myself and not do stupid things. Which I said that I wouldn't do that, because that's why I try not to encapsulate things too much. The adapter graphics, and this is the type of value that this is. But that's not what it is, right? This is the type, but it's not the variable name. The variable name has memory. So has mem, right? And if you really wanted to keep track of the type, you could put like this: u32 val equals 1. And then we can just make the note up here. So adapter graphics.has memory, and we'll set it to 1. And then after we've set that to 1, we're going to persist it onto the GPU side using our put method, supplying the context adapter, or not the context adapter, but the graphics adapter, and the variable we want to persist. Now, yeah, that's good enough. I mean, you could, if you wanted to use a more object-oriented approach, right? This GPU variable container, it would kind of like contain the adapter, the graphics adapter, so that you didn't have to supply it like this, right? Because maybe you think that having to supply this as the first argument is very redundant and annoying, but it also would create some dependency loop kind of issues, right? Because we already noticed that this is adapter graphics.gpu variable controller, and if the GPU variable controller also contains adapter graphics, right? Now we got some trouble, right? Because now, right? So we'd have something like adapter graphics.gpu variable controller, but then in GPU variable controller we have something called GPU variable controller adapter graphics, right? So now we got this cyclical dependency loop, and it's like one of those. It's an artificial dependency loop. It's just a that's what happens when you over object orient your code and mix together. When you tightly couple functions and data when they don't need to be tightly coupled, and then you'll get all these dependency loops that don't have to be there. And so that's kind of why I have decided to write it this way. So let's really quick, let's refresh and see if this is working now. I don't know why I am refreshing the timer. Okay, so adapter graphics has memory, and we're gonna. Oh, got it, because it's the U32 value inside of it. That's what I did wrong. So I still have screwed this up. So it's dot U32 value. It's not. Okay. So if I change that to U32 value. Okay, fair enough. That looks good enough. So, okay, now I'm going to refresh again. Okay, so now we have adapter graphics has memory and the U32 value, and we're going to set that to 1. And so let's step through this, because this is the first time I've seen this code in action. So the U32 put function takes the adapter graphics, and then it takes the U32 value. Yeah, I mean, that is a little... I mean, that's slightly obtuse, the way I did that. I'm not gonna... Yeah, I'm gonna... It's good enough. Context graphics is there. So the U32 location, we're gonna fetch that. Okay, so we go in here. It does have a name. So the location right now is 0, because we have not yet fetched the so the has lock for the has location. It hasn't been set yet. So we're going to flag it as set right away, even though technically this is not true yet, but I do it right away because it lines up right here, and then I don't have to remember to flag it as true after we're done. And it's also nice to flag things at the top like this. If you're doing something that might involve recursion or accidental recursion because of a flag, it's nice to flip the flag before you do the operation, just to avoid that problem. Let's see, U32, right? So there's the U32 location, equals, and then we're going to get the uniform location, and this is the location. Right now it says 0. We might get something back though, so let's I'm gonna put a breakpoint here and play. Get uniform location. Okay, and now Well, that's nice. Now it says null. Why does it say null? Well, that would probably mean that it's not actually in the shader, is what that would mean. And if we're gonna say has location, but we just got back null, that's no good. Because now we think it's working, but it's not working because it returned null. To fix that, right, we want it to fail as fast as quickly. It's probably returning null because the value is not in the shader yet, and I just, I wanted to eventually put that value in the shader code, but I haven't yet. So let's. So here's our U32 location fetching code here, and here's where we enter, and then we set the location here. And what we could do is, do we want to check for a null location value outside of this if statement, or do we want to check it? Let me think. U32 location. I guess there's a lot of stuff that could happen between this if statement and exiting. Oh, sorry, you can't see that. There's a lot that could happen between this block of code and this variable here. And what we want to know is we want to make absolutely sure this is valid. So I'm going to say that at the very end of the function, right, because all this function is doing is it's caching the location for that uniform within the shader. Yeah, so right at the very bottom, we're just going to do a check to say that if null equals this or false, actually, we probably shouldn't do that because the location could end up being 0. We saw that it returned null when it wasn't there. So uniform locations. Let's look at that. I'm pretty sure a valid uniform location can be 0, so in like the C version. So I don't think we want to do a check for 0. So yeah, so let's see. What do we want to do? We want to do get uniform location. And let's see what that says. GL get uniform location. Specifies the program to be queried. Points to a null terminated string containing the name of the uniform. Okay. So what I want to know is that return value GLInt. So the return value. Okay, function returns -1 if name does not correspond to an active uniform value. Okay, so knowing that, so I'm just looking at how it's implemented in the C code, because that gives me a little bit more insight as to what's going on. And then here, when I'm checking to see if it's valid, I know that the WebGL is doing this. WebGL. And then we could say 0 -1 -1, or if if 0 is greater than, so instead of just checking for -1, I'm going to check for negative. So u32.varlock.u32 location, right? So if 0 is greater than, right, and we can read this backwards, so if this is less than 0, so if it's negative, right? So we're going to check for both of these, and I'll make a note that this is C99, C11. Okay, and so that's a little bit redundant, but this is just a note for me personally, so that when I'm like trying to transcribe this into C code, I'm going to be like, no, that doesn't make sense. I thought these were supposed to be integer values, right? Because the location is supposed to be a handle. Or, yeah, well, the location is just supposed to be a GL-int. It's not quite a handle. It kind of is a handle. Handle-ish. So comparing a number to null doesn't really make sense, but that's what I saw in the debugger. So I also want this for when it's in C code. So, right, so it's not quite a one-to-one mapping between the C version of OpenGL and the WebGL. And I want to understand those minutiaes of the minutiaes. I think minutia means the minute differences, the small distinctions. Okay, so if we get this, does uniform exist in shader? And then console.log. Also, actually no, we'll just make a note here. Also note that shader variables can be optimized out of your shader code if you do not use them. Right, so if you declare them, but you don't use them, then they can be optimized out. Declared, but not used. So just a little summary of that. If you declare it, but you don't use it, it can get optimized out of the shader. And then when you're trying to fetch the uniform value, you won't be able to find it because it's been optimized out of the shader, which gets me a lot. So I'm just going to put that in there. So now, when we step through... Oh, God, I gotta stop again. Stop